The concept of drumming is really interesting from a robotics perspective. It's full of fluid motions juxtaposed with a need for rigid and consistent timing. For this project, our goal was to use this 3 degree of freedom robot arm kit to emulate the motions of a human drummer while keeping that consistent timing that robots are so good at. First, we made some modifications to the robot arm's gripper. When a human picks up a drumstick, they'll generally create a pivot point between their thumb and index finger. This lets the stick freely rotate and rebound off the surface of the drum. To emulate this, we 3D printed a pivot point so the stick can rotate freely while still being attached to the arm. To control the amount of rebound you get from the stick, human drummers will either clamp down or loosen up the rest of their fingers on the back of the stick. We used a servo and another 3D printed part to recreate that for our arm. To create the trajectory, we started by looking at some research documenting the mechanics of a drum stroke. In this 2004 paper by Sophia Dahl, the trajectory of a drumstick was tracked throughout a drum stroke. In this image, you can see the shoulder moves a little bit, the elbow moves more, the wrist moves quite a lot, and the tip of the drumstick traces a huge arc. This shows that each joint is contributing to the overall motion, which lets you get a much higher velocity than you could get from any individual joint on its own. We broke our trajectory down into a few different distinct motions. For this joint, the elbow, the arm just moves up and back down. For this joint, the wrist, it moves down to prep, way back to wind up, and then it follows through for the impact. We created a 5th-order polynomial for the angular position of each motion. We started at the joint's maximum acceleration, which is about 25 radians per second for the elbow and 50 radians per second for the wrist. Then ramped it down to the maximum negative acceleration. From here, we can create a position time curve and send it to each servo through the Arduino. Since the amount of time given for each stroke will change depending on the needs of the music, the size of the stroke will also change. With this approach, the arm will make as large of a path as possible for a given length of time. By changing this length of time, we can implement different stick heights and volumes. When we combine this with the open or closed gripper, we can get a variety of different results. Now, we can convey actual beats and rhythms to the arm through MIDI. MIDI is a serial data transfer protocol that gives us volume and timestamp information for each note from almost any music creation software. We can process that in MATLAB, then transfer the times and stroke types over to the Arduino. That results in a robot arm that can do this.